Hello friends, welcome to your only channel Times of Coding. Today in our series Scala Express, we will learn about implicits and companion object. This session will help you to low-couple your code and work with imports while programming and design view objects. In previous session we have seen Scala packages, Scala import. In this session we will learn implicit import, access modifiers, access qualifiers, companion object and package object. Scala by default implicitly imports following statements in every program, like import java.lang. This we don't need to mention in any of the classes while writing code. Next is import scala._, and then next is import predef._. For these following packages import, we are getting access for these java.lang package by using import java.lang statement. Here we are accessing Scala package and here we are accessing predef object. Since java.lang package contains standard Java classes, it's always implicit import JVM implementation of Scala. The .NET implementation would require system packages instead, which is .NET analog of java.lang package. Because java.lang always get imports implicitly, you can write thread directly. You don't need to mention java.lang.thread. And in scala._ here, this is the standard Scala library package with many common classes and objects. Because Scala imports implicitly, you can write list instead of scala.list. And then next was the predef. Predef object contains many definition of types, methods, and implicit conversion. And these definitions we actually uses in Scala program. So we can write assert instead of predef.assert. This assert we will in fact explore in one of our next session. Okay, if we import later also the same package, our import statement will be overshadow. Moving to access modifiers, just like any another language in the market, Scala do support for access enabler to its package, classes and objects, so we have full control and provide restriction according to business use cases while programming in Scala. Now we will see example of private access modifier. So in this example, I'm defining one class as family and then I'm defining class family head. In that family head, I'm defining one member function here to get the locker keys. And in that locker keys, I'm keeping 7070 as the passcode. Inside that family head, I'm defining family members and these family members will be calling get locker keys function. Inside the family, I'm having one another class definition as guest. And this guest will have a take advantage member variable, and this take advantage will have an instance of family head. Now this take advantage can get lockers also because it is an instance of family head. We'll see how this will behave in actual runtime. But this take advantage object of family head class can get advantage of get locker keys because this class has been defined in the family. But that idea won't be possible because here get locker keys we are defining as private. So it is only accessible inside this class, nowhere else. In above example you run, you will get below compile time error that this method is not available. And see likewise compile time error we were having. Family head cannot be accessed as a member of family from class guest in class family. So that's what earlier I was talking about. So unlike Java, Scala only supports inner class access to its private member. So if inside the family head, if we have defined the guest class, then this class can access through all its private member, otherwise no. Now we will see another demonstration of protected member now. And in fact, if you compare with Java, even this is having little restrictive nature in Scala. Scala protective modifier always and only support subclasses access, but do not allow access in case of same packages. So here I'm defining class super access and in that I'm keeping one method called enable and I'm making as protected. So this will simply get us one debug message called access enable. And then I'm defining one another class called authorize access. This authorize access will extend the super access class which we have defined here and that will simply call the enable method as we have discussed here. And then I'm defining another class called front desk. and this will also try to make the call to same enable. But since it is not a subclass and this function is a protective, front desk will not have access to super access class method enable while they share in fact the same package. Okay, so moving on, in Scala, whatever methods we don't define any member of any class as protected and private, by default it will have the public accesses. That means anybody from anywhere, any functions or any object can access that particular function. Now for convenience, few evangelists and few technologists call this public method when we do not write public called as default. But to me, calling public these default or not written any access specifier makes sense. So I'm just calling public, and going forward also I will be using public word for not defining any access specifier in our session. So I hope we are so far so good with this content. Now next topic of interest for our discussion today is qualifiers. Qualifiers takes access modifiers to next level. But that means we can define private and protected to class, package or singleton object level. What I mean by that sentence, I will show you in this example. So here we are defining one package called family. Inside that package, I'm defining another nested package as parent. And inside that package, I'm defining one class called locker. And this class, I'm defining with private access modifier with family qualifier. So when I say family qualifier, that means all the guys inside this family can have access to this locker class. And now inside this class, I will keep it get locker code as member variable. In that locker code, which we have seen earlier also, I will define like a protected access modifier, and here I will give it a qualifier as parent. That means inside this package, everybody can use this code as per protected conditions. Now inside this locker class, I'm defining class called money. This money will have qualifiers at locker level, that means at this class level, and that too private. So here we are defining one function called get money, which will ask you code and it will give you boolean result. The other function inside this locker class I'm keeping as ask parents. It is the same replication when we ask parents for money. So now in that case, I'm defining new object for money class, and then I'm getting the money out of this money class by invoking get money function here. And in that get money, I'm using the get locker code by default. So far, if you understood this code clearly, to get money without asking parent, it could be challenge here as per this definition, but to ask parent, it is the most simplest thing we can do. Now we have seen the definition part so far. Moving on, we will see the object invocation. So here I'm defining one package called children, and then we are importing parent locker. This is what our main interest point so far. So here inside that parent, we are having locker class. So that we have imported successfully here. Now object adult, that means the children who got into adult state, they will extend the locker. Now inside that, I'm making one main method. We need to bring these code in scope of execution. So I'm defining main here, and then I'm keeping new locker instance in a variable called take money. So basically take money will be a variable reference for this new locker class object. And then we will have take money dot get locker key. Since take money is a kind of locker object, we can easily get money. We can easily get locker code. So our next interest would be to supply this locker code, and here I'm trying to get money with the code. Now when I try to run this code, it will get us compile time issues. Since we are trying to get the locker code which has qualifier. Now if you see, the locker code is having qualifier as parent, and we have defined this object in children. That means as per condition of qualifiers, this is out of the scope. So that means our compiler will throw some issues at this statement. So with this option, we have exhausted all the options to get money. If we can't get the locker code, we can't get the money, because get money function require the locker code as prerequisite. So only option left to ask parents, and that we will see in this object definition. So here I'm keeping same till here, it is same, and then we are defining take money. I'm creating new object of locker class as earlier, and instead of getting locker code by myself, I'm simply asking the parents. And when ask for parents, there is no restriction of access modifier, so we will successfully take money. Now when I print this, this will get us the money through parents kind of authorized transaction we can call. So here we have covered the access modifier and the access qualifier. Now moving on, there is one object type which we defined as companion object. From the name itself, you might have understood that companion means husband and wife type. So that means there will be no restrictions to access the private property. Scala do not support static members, but in this companion object with class name, if they are sharing same name, this definition will become the companion object type. And here you can keep all the static information. So in Scala, instead of static members, we need to define every information or member of this class, which we are treating as a static inside the object. Now here I'm defining class restaurant, and this class restaurant is actually importing restaurant.guestage. If you see, this is coming from the object here. And inside this object, we have defined this guest age as private member. After defining private also, we can access in class. That's what the beauty of companion object. And then next, if you see definition, I have defined can get liquor. And in this, we are passing a restaurant as one of the parameter. And this method invocation will return the boolean type. So here I'm defining one condition. If restaurant dot is age legal matches, then only we will get yes, you are at legal age to consume liquor debug message, and then we will get true. Otherwise we will fall under else condition, and then we will get a debug message as drink juices babies, they are tested too, and then we will keep it written false. To invoke this functionality, we need to define main first inside this object, and then we will have an invocation to this function. Now if you notice one thing here, the is age legal function which we are using inside one of the function of this object, it is actually defined inside the class as private here. So you see here we were using private member function class inside the object, and from object we have defined guest age as 19 as private, but it is getting used inside the class. That's the beauty of companion object in Scala. So far in our sessions, we have only defined classes, traits, and object at package level. But this is not only the scope which has given through Scala. Scala in fact support object at package level. So think about any use case where you need actually mutual interest dependency at package level. And that we need to keep at package level. And since it is defined inside the object, it could be treated as a static type. Though there is no static in Scala, but it is for our interpretation. That's how we can understand if we are coming from the Java background. Okay, so in this example, I'm defining one package object. Let me repeat, I'm not defining package here, I'm defining package object. And this package object I'm giving as wedges. So inside that package object wedges, I'm defining get wedges. And this get wedges will get you the string type of information. And here I'm defining potato, tomato, onion, and likewise vegetables name. This was about the definition of package object. Now we will see the invocation of package object functions. Inside the same package, we are defining one object called wedges object. And inside the main of that object, we will invoke that get wedges method, since it is returning string value to get that value on console.io. So after execution, we will get all the output at console.io of our ID. With this example, we have discussed today content and how Scala gives us absolute freedom while defining things at any level, be it by using access modifiers or access qualifiers, and inside we can keep our member definition at package level. But yes, while defining those things, we need to understand the scope of feature, and we need to decide by taking cognitive decisions. Now it's time to do practical of the same examples.
Okay, so our IntelliJ started. Now first we will create a package called companion objects, and in that package we will create a Scala class called family. This was the first example we have seen today. Now I will create this class. So here we have defined family class and family head class, and then we have defined get locker keys as 7070 with private, and inside that family head I'm defining one family member class also, and with this family member class we are keeping one method call to get the locker keys. Now since this is private here and we are trying to access the inner class, it is okay for Java compiler. But when we are defining guest class, and this class we are defining at family level class, and then we are trying to get the object from family head, and this take advantage object is basically wanted to take advantage of this family head privileges. So here we are accessing with this take advantage object to get locker keys, but here our compiler is scolding us that we cannot get. That's why it has got red underline. So here if you see, get locker keys is inaccessible from this place as we expected. Now after this example we have seen the example of super access type class. So I will create one class now. Okay, so here we are defining super access class, and then we are defining authorize access class, and here I'm keeping my method as protected. And since we are defining this as subclass of super access, we can call the enable, but if the same we will try from front desk without extending super access, even though we are sharing the same package, this will not happen. That's why it is coming as red. If you just hover your mouse over, you will get cannot resolve symbol enable as we expected, because Scala is little restrictive with protected. That's why it is not allowing access to same package classes also. So after this protected access modifier, we have discussed about public. So far in our most of the sessions, we have discussed and we have defined our functions, our classes as public only. To get the definition, I will let you explore, and I will move on the next topic as qualifiers. So to understand access qualifier, we need to define one class as locker. Okay. So I'm defining this locker class inside the family package and then parent package, and here is the class which we expected to have. And this was the definition of this class which we have seen in earlier theoretical example also. After that we are defining children package, and in that we are importing parent.locker, that means this class, and then we are defining one object called adult, and here we are extending this adult class as locker. Since this class comes under the family type of access qualifier, we can extend likewise. Then to bring code in execution scope, we are defining main inside this object, and then we are creating one object of locker class, and then we are trying to get the locker code. But since we are defining this code inside the adult, which is children type, let's see if it gets accessible. So I will execute now. So if you see here, get locker code in class locker cannot be accessed as a member of companion object family parents locker from object adult in package children. That means our adult children cannot access the locker class. So this way we have exhausted all the option to get the money from parents locker without asking them. So now what is the available option we are having in hand? Since we have defined this function as ask parent, we will use the same here. So now I will give it a call to ask parents, and here we will print the same. So after execution we are getting true. So our transaction is successful. Now why we are getting true? Because here I have given true inside the get money. But in case of your actual business case, you can write any if condition on basis of getting locker code, and you can check the balance. You can authorize the locker code whether it is expected or not, and likewise things you can perform here with the help of conditional statements. Now this was the example of qualifier. Our next topic was the companion object. So in order to understand companion object, first we need to create a class called restaurant. And after creating this class, I will explain you a little bit again. So here I'm defining one class as a restaurant, and the same name I'm defining one object also. This class is having two things, import statement and private definition of isLegalAge function. Now if guest age is greater than or is equal to 21, this will get us true, otherwise it will get us false. Now inside the object of restaurant, what age we are keeping as guest age is 19. So technically this condition should get us false. Now we are having one function called canGetLiquor. While canGetLiquor, we are having if condition. On basis of this we will have true, otherwise we will have false. So with this false and true, we are having some debug messages also. In order to execute this object, we need to have main method, and here I'm calling the canGetLiquor with new restaurant type. Now I will execute and we will see the outcome. So see, the debug message we are getting here is drink juice babies, they are tastier too. Now if you understand the logic here, why we are getting the trouble with getting liquor, because we are having guest age as 19, and in our legal age condition we are having 21. So I will make guest age as 22 now, and if we execute now, we will get message yes, you are at legal age to consume liquor. So that's how companion object access each other private member functions. So here the class is actually accessing the guest age, which is private in object, and here inside the object we are accessing the isLegalAge function, which is actually private of restaurant class. So this is what we have discussed in earlier session also about the companion object. Now moving on, we have discussed package object. To define package object, first we need to create one object, and that we will call as veggies. So here I'm defining package object called veggies, and inside that veggies package object I'm defining one function at getVeggies. Okay, this getVeggies will get us a string type of vegetables names as potato, tomato, and likewise. Now this was about the definition of package object. In order to understand the invocation of this package object, we need to create one object as veg object, and in this object I will create one main method, and here I will print getVeggies. This getVeggies is the same method which we are importing from veggies package object here. So if you see inside the package object veggies.getVeggies, and the same we are importing here. So now I will run this object, and we have got outcome as expected. So with this example we have covered today content about implicit imports, access modifiers, access qualifiers, companion object, and package object. I hope you enjoyed today's session. Thank you. Have a good day.